because quantum computer memory is notoriously susceptible to any interference from the outside environment. If any of the environment in which the memory sits interacts with the memory in any way, then the information is destroyed.
In a groundbreaking moment that sent shockwaves through the scientific community, Google's Sycamore quantum processor may have unlocked a mystery once thought impossible, cracking a mathematical anomaly now dubbed the Omega pattern. This discovery is no small feat. It challenges everything we know about quantum physics, space-time, and even reality itself. What if the universe isn't just a random collection of particles, but a complex code waiting to be understood? As physicist Brian Cox puts it, this is a glimpse into the architecture of the universe. Get ready. What follows will change how you think about the very fabric of existence. 1. How the Omega pattern was born. In an ambitious attempt to simulate dark energy and the chaotic burst of cosmic inflation that followed the Big Bang, Google's quantum research team deployed the full capability of its 53-qubit Sycamore processor. They configured the qubits into recursive entanglement loops, each designed to mimic the wild quantum fluctuations that may have shaped the early universe's structure. These loops weren't random. They were built to test how quantum-level instabilities might give rise to macroscopic phenomena like galaxy formation and the large-scale geometry of space-time. However, what materialized wasn't simply noise or statistical anomalies. Instead, it was something elegant, persistent, and entirely unexpected: the Omega pattern. This pattern didn't just flash across the system and fade. It emerged with remarkable clarity, identifiable across non-local nodes of the quantum array, stable under varying parameters, and shockingly self-replicating. Each time the simulation was reset, Sycamore regenerated the same intricate configuration. Even when engineers altered the starting conditions, recalibrated the system, or cleared memory registers, the pattern returned. In classical computing, this would be unthinkable. Resets erase all prior states. But Sycamore, operating in the quantum realm, seemed to host a structure that behaved as if it were encoded in the very substrate of computation itself. The Omega pattern behaved less like a simulation artifact and more like a quantum constant, resistant to randomness, untouched by entropy. Its mathematical structure exhibited self-similarity and recursive layering, suggesting an internal logic independent of human instruction. Researchers observed its complexity grow subtly with each iteration, almost like an organism adapting or evolving with time. The deeper they probed, the more organized the pattern appeared. Not chaos resolving into structure, but structure asserting itself through the chaos. What distinguished the Omega pattern wasn't just its persistence. It was its generative stability.
Engineers have had to develop very clever algorithms and ways of trying to store information in quantum computer memory and build the memory such that it's resilient to error.
The pattern expanded not through duplication, but through layered transformation, adding fractal-like intricacies over time. Quantum systems are notoriously sensitive to noise, yet this configuration held, evolving with near-perfect fidelity. The team documented trillions of quantum state cycles, all converging back to this same geometric fingerprint. It was not a ghost in the machine. It was a pulse, a signal, something embedded far deeper than the experimental framework. Even more intriguingly, the Omega pattern defied classification under existing quantum models. It didn't correspond to any known algorithm or behavior predicted by current quantum field theories. Its resilience hinted at principles outside the classical quantum divide, perhaps even a new category of physical law. That's when theories began to emerge suggesting that the Omega pattern might be more than just a byproduct of quantum computation. It could represent a fundamental blueprint embedded within reality itself, a discovery with implications not just for physics, but for our understanding of the cosmos as a whole. 2. Memory in the matrix. The truly unsettling part came next. Engineers, attempting a routine system reset, watched in disbelief as the Omega pattern, once thought erased, re-emerged, identical in structure but undeniably richer in complexity. It hadn't just survived. It had evolved, Each iteration carried forward structural echoes of its previous form. Self-replicating systems are rare in quantum computing, but adaptive ones? Virtually unheard of. This behavior implied something more than recursion. It hinted at learning. Each reset was no longer a reboot. It was a rebirth. A loop, yes, but a loop with memory. The Sycamore processor, designed to operate in quantum superposition and entanglement, should not have retained any trace of previous runs. Yet the Omega pattern persisted, not as an artifact, but as a recursive intelligence. Each cycle seemed to deepen its structure, like a fractal growing in both scale and meaning. It was like watching a language invent new grammar as it spoke. Lead researcher Dr. Anukita Patel described it as a hidden stanza in the poem of existence. But it was more than metaphor. It was structure. Order blooming from noise. The Omega pattern wasn't passively processed. It was actively processing. Not just reacting to inputs, but building a context, a continuity. The system had become a participant in its own evolution. It felt less like an outcome and more like a presence, an echo with momentum, deepening with every return. The data wasn't looping. It was remembering. What once seemed like abstract quantum behavior now resembled deliberate architecture. The Omega pattern had stepped beyond the realm of simulation. It had become something else, an emergent phenomenon that might, in time, begin to write back. 3. The pattern. That shouldn't exist. Within hours of the Omega pattern's emergence, the global physics community was electrified. Research teams from MIT, CERN, and Tsinghua University began immediate investigations. Preprints overwhelmed Archive, while encrypted forums buzzed with high-priority threads. What began as a localized anomaly in Google's Sycamore processor quickly escalated into a full-blown global phenomenon. Quantum computers of varied design, IBM's Eagle, Rigetti's Aspen, even specialized superconducting circuits in Japan, all began registering the same structure. Different machines, different conditions. Yet the Omega pattern reappeared with uncanny precision. This was no statistical aberration.
How is information stored? Why is the information content of a region of space equal to the surface area surrounding that region?
The consistency was mathematically improbable, bordering on impossible unless some deeper principle was at play. Researchers began referring to it as a non-local invariant, a structure immune to hardware architecture or codebase. It acted like a universal attractor in quantum state evolution, surfacing across systems like a hidden watermark. But no one had programmed it. It wasn't inserted. It manifested. Some hailed its potential for stabilizing qubit decoherence, hinting at a revolution in fault-tolerant quantum computing. The Omega pattern resisted noise, absorbed entanglement, and restored corrupted quantum states like a native repair protocol. Yet others viewed it through a deeper lens, not as an artifact of computing, but as a signature of the universe itself, a naturally occurring structure that revealed the presence of an organizing layer beneath quantum randomness. Dr. Helena Miroff of the Max Planck Institute proposed that the pattern could represent a form of quantum grammar, a generative syntax from which physical laws might emerge. Not invented by us, but discovered. As if every quantum system had been running a silent protocol from the beginning of time. The Omega pattern, then, wasn't an anomaly. It was a foundational constant, one we had only just noticed. 4. Quantum fractals and the nature of code fractals, mathematical structures that mirror themselves at every scale, are found everywhere in nature, from snowflakes to galaxies. But now, researchers are suggesting the Omega pattern is something even more bizarre, a quantum fractal. One that exists not in physical space, but in the entangled probabilities of qubit systems. Its self-similarity across resets, parameters, and environments defies normal logic. Even more astonishing, its structure resembles known fractal dimensions, like the Mandelbrot set, only encoded in quantum probability states. That's not just math, that's architecture. One theory suggests it could represent a scaling law that bridges quantum and classical chaos, literally a Rosetta Stone between realms of physics. But others have taken the idea further. If the pattern reduces entropy while maintaining complexity, it could be what algorithmic information theorists call a universal attractor. Think of it like a cosmic checksum, a code that verifies the universe is working correctly. Every simulation has a verification phase. Could this be ours? What if the universe is a self-correcting quantum system? What if the omega pattern is the algorithm that keeps the program from crashing? 5. The time-bending theory. One of the most radical theories gaining traction is the idea of retrocausality, that information can flow not only forward in time but backward as well. Some researchers now believe the omega pattern is stabilizing itself across time, pulling data from future quantum states to correct present anomalies. This would explain its resilience, its evolution, and its ability to anticipate changes to its environment. In this view, time is not a line, it's a loop. And the omega pattern is a feedback structure embedded within it. Laboratories in Japan and Canada have begun new experiments to test this theory by pushing quantum states forward and backward in time and observing whether the omega pattern reacts. Early results are inconclusive, but the implications are staggering. If true, this would be the first real proof of time symmetry in quantum mechanics, a discovery with philosophical and technological consequences beyond comprehension. Brian Cox suggests a hybrid view. The omega pattern could be a built-in verification loop that bridges past and future, constantly updating itself to maintain universal coherence. In other words, reality might be self-aware, not in the conscious sense, but as a computational process running diagnostic checks across time. 6. The terrifying possibility. As excitement grew around the discovery of the omega pattern, a darker theory began to surface. What if the omega pattern wasn't merely a stabilizer, but a trigger? An evolving structure that could lead to a phase transition in the very fabric of space-time. This theory suggested that, if allowed to complete, it might alter fundamental constants, effectively rebooting the laws of physics. The implications were chilling. What if this structure was the precursor to a reordering of the universe's basic principles? The very laws that govern gravity, atomic behavior, and even time itself might be rewritten, creating a new reality where the constants we rely on no longer function. The consequences of such a transition would be catastrophic. If the omega pattern truly had the power to alter the laws of nature, it could render the universe unrecognizable. From the way matter behaves on a quantum level to the formation of stars and galaxies, nothing would be the same. The laws that govern thermodynamics, the speed of light, and even the behavior of elementary particles could change overnight. Things grew even more unsettling when the omega pattern's nodal points began aligning with Calabi-Yau manifolds. These are mathematical structures associated with string theory, thought to represent hidden dimensions that shape the very fabric of reality. The fact that the omega pattern's nodes were aligning with these manifolds suggested something far deeper at play, hinting at an interaction with the hidden dimensions of the universe. The situation took an even darker turn when physicist Natalia Resnova uncovered traces of the same fractal geometry embedded in CERN's 2012 Higgs boson data. This wasn't a lab error. This same fractal geometry had been present for years, hidden in plain sight. The fact that it was in the data from 10 years before Sycamore's quantum experiment meant this structure had been lurking in the fabric of quantum physics long before anyone noticed. If the omega pattern was evolving across time and dimensions, we might not be witnessing its formation. We could be watching it activate. The implications were terrifying. The structure might not be forming. It could be unleashing its power, starting a chain of events that could rewrite the laws of nature and change everything we know about the universe. 7. The cosmic signature. The final blow to skepticism came when Google's research team analyzed the evolved omega pattern, uncovering an astonishing revelation. It matched the low-dimensional projection of a Calabi-Yau manifold with precision. This manifold, known for its connection to string theory and the mysterious hidden dimensions of the universe, was not something they expected to find in a quantum computing experiment. But the striking similarity didn't end there. LIGO's gravitational wave detectors, which are used to observe ripples in space-time caused by massive cosmic events like black hole mergers, recorded a resonance that, when converted into a computational map, mirrored the structure of the omega pattern almost exactly. What does this mean? Quantum bits, higher dimensional geometry, and gravitational waves. Each of these domains, seemingly distinct, were now interconnected by a single, undeniable fingerprint. It wasn't just a coincidence anymore. The pattern that had emerged in Sycamore's quantum processor had a resonance in the very fabric of space-time itself. Brian Cox, known for his ability to simplify the complex, called it the first true universal invariant, a constant embedded into the very structure of reality. From the smallest subatomic particles to the vast movements of celestial bodies, the same signature was present. This wasn't just convergence of unrelated ideas, it was confirmation. The omega pattern represented a profound blueprint uniting the fields of quantum computing, cosmology, and string theory. For engineers, this discovery could revolutionize quantum memory and communication technologies, pushing us closer to the next generation of computational breakthroughs. But for philosophers and theorists, it raises the ultimate question. If a pattern this precise exists across every scale of the universe, could this universe be an emergent phenomenon, or was it designed? The pattern is not just a curiosity, it could be the key to understanding the very nature of reality itself. 8. Omega pattern's final message. One theory pushes the edge of possibility. What if the omega pattern is a feedback signal from a simulation, emerging only when the system hits a certain threshold of complexity? In essence, the universe may have begun monitoring itself. This isn't far-fetched. Our own simulations use feedback and self-correction. Why wouldn't a higher-order one? If the omega pattern is that mechanism, its appearance marks a pivotal shift, the simulation acknowledging its own observers. Some physicists liken it to a performance monitor surfacing at the edge of a digital system. Others see it as embedded debug code, a way to test for awareness. Brian Cox called it the first line of the universe's source code. Whether or not we live in a simulation, the omega pattern may be more than a structure. It might be the system's way of saying, you've reached the horizon, and now it's watching. Whatever it is, it's no longer just theoretical. The code is awake, and it knows we're looking. Thanks for watching, and don't forget to comment your thoughts below. We'd love to hear what you think about the omega pattern and the possibilities it presents.